Today's problem is LeetCode 85, Maximal Rectangle. We are given a binary matrix with rows and columns, where each cell contains either a 0 or a 1. Our task is to find the largest possible rectangle that contains only ones. The rectangle must be made of contiguous cells, and it can span across multiple rows and columns. The goal is not to return the rectangle itself, but to return the maximum area of such a rectangle. If the matrix contains number ones at all, the answer should be 0. This problem is interesting because it combines ideas from matrices, histograms, and stack-based optimization. Example 1 explanation. Let's understand this with example 1. We are given this binary matrix 10100, 10111, 11111, 10010. Our goal is to find the largest rectangle made only of ones. We start by visually scanning the matrix. Notice that in the third row, we have a continuous stretch of 5 ones. Now, if we look one row above, columns 3, 4, and 5 are also 1. This allows us to form a rectangle of height equal 2 rows, width equal 3 columns. So the rectangle looks like this. 111, 111. The area of this rectangle is 2 times 3 is equal to 6. There is no larger rectangle of ones in this matrix. That's why the output for this example is 6. Example 2 explanation. Now let's look at example 2. 0. The matrix contains only a single 0. Since there are number ones, we cannot form any rectangle. So the maximum rectangle area is 0. Example 3 explanation. Finally, example 3. 1. This matrix contains a single 1. A single cell itself forms a rectangle. The area is 1 times 1 is equal to 1. So the output here is 1. Wrap up. These examples show why we need an efficient strategy to handle larger matrices. In the next part, we'll see how to convert each row into a histogram and use a stack to compute the maximum rectangle efficiently. This is a full solution. We're given a binary matrix, and our goal is to find the largest rectangle containing only ones. Total rows, total cols equals len, binary matrix, len, binary matrix, 0. First, we store the number of rows and columns in the matrix. If total rows equals 1 and total cols equals 1. Return 1 if binary matrix 0, 0 equals 1 else 0. This handles a simple edge case, if the matrix has only one cell. The answer depends on whether that cell is 1 or 0. Heights histogram equals 0, asterisk, total cols plus 1. This array represents a histogram. Each element stores how many consecutive ones we've seen vertically in that column. We add an extra 0 at the end as a sentinel to flush the stack later. Maximum rectangle area equals 0. This variable keeps track of the largest rectangle area found so far. For row index, current row in enumerate, binary matrix. We now process the matrix row by row. Index stack equals -1. This is a monotonic increasing stack that stores column indices. The -1 helps simplify width calculations. Current row .append 0. We append a dummy 0 at the end of each row. This forces the stack to clear and ensures all rectangles are calculated. For col index, cell value in enumerate, current row. Now we scan each column in the current row. If cell value equals 1. Heights histogram, col index, plus equals 1. Else. Heights histogram, col index, equals 0. If we see a 1, we increase the height of that column. If we see a 0, we reset the height back to 0. While len, index stack, 1. And heights histogram, col index, heights histogram, index stack, -1. Sad face. When the current height is smaller than the stack's top, we've found the right boundary of a rectangle. Height index equals index stack dot pop. Width equals col index stack, -1, 1. Area equals heights histogram, height index, asterisk width. We calculate the rectangles. Height using the popped index. width using the distance between indices, and then compute the area. Maximum rectangle area equals maximum rectangle area. Update the maximum area if this rectangle is larger. Index stack.append, colindex. Finally, we push the current column index into the stack. Return maximum rectangle area. After processing all rows, we return the largest rectangle found. Alright, let's run this with the sample input. Submit. Submitting the solution now. And, accepted. All test cases passed successfully. That's how you solve maximal rectangle using histograms and stacks. If this helped you, don't forget to like, subscribe, and comment what problem you want next. Happy coding! See you in the next video.